Hi everyone, this is going to be a series of tutorials introducing everybody to the Monkey2 language. And I want to let you guys all know that I'm doing this in dedication to my lovely girlfriend Safa. I'll start it by opening the file main.monkey2 and giving my file a namespace of tutorial. And that basically means anything in this file is accessible under tutorial, and any other file with the tutorial namespace is included with this file in some sort of way. Now I'm going to give myself the entry point of the Monkey2 program by using a function called main in between the function block all the way to the end keyword. I want to say hello world, so all I'll have to do is type the keyword print and use the string literal hello world. Now if I press F5, or even better, build and run, I should get the output here, hello world. Next, I want to replace this hello world literal with an actual value that I can change from or manipulate over time. So I'm going to give myself a local value, a local variable, and I'm going to call it hello world. I'm going to declare what kind of data type it is because Monkey2 is a typed language. So I'll use the colon and then define the data type here, which is string, and set it equal to a value, hello world. I'm going to replace my literal here and put in the variable, and now it should almost do the same thing, and it does as I expected. But what happens if I want to use this string somewhere else in the program? Well, this is a local variable, so it's only accessible here. What if I want it to be accessible to anybody using this or referencing this namespace? All I gotta do is take it to the outer edges of the file outside of any block, give it the global namespace or give the global scope by using the global keyboard. I'm gonna call it hello world, capitalize it. And instead of defining the actual data type this time, I'm going to use a shortcut and use colon equals and then the value I want, which is hello world. Now I can access this hello world variable from anywhere in the program as long as it's referencing my tutorial namespace. And now I should see hello world twice. Easy as that. There's a problem though. Anybody in the program can now mess with my variable and change it, like reassigning it using the equals assignment operator, like this, not hello. And all of a sudden, it's going to be printing out now. It's not going to be printing out hello world, it's going to be printing out not hello. So if I want it to be, out in the open for anybody to reference, but I don't want anybody to change it, I'll use, instead of global, I'll use constant or the const keyword more appropriately. And now I have the ability to get a compile error, which somebody else trying to change it will also get. So it's impossible. One more thing, or two more things regarding strings, is that Monkey2 offers multi-line strings. So I can actually have something like this where it takes up multiple lines. And when I print it out, it should do the same thing in the console, and it does. But I don't like that tab spacing there. So I'm actually going to remove those tabs because if you have the tabs there in the actual IDE and the file, then it's also going to print those. So Monkey2 does not remove that white space before. You have to push it down to the left if you're going to be using this multi-line format. Also, you're going to be seeing a new line because you need to delete the line between here and the first line. So it needs to look something like this if you want it to look really clean. One more thing is that some people might want to actually put a quote in between both of these, but you're not going to be able to do that. You're not going to be able to put that double quote here because that'll just end the string. Monkey2 and pretty much any other language isn't able to determine what an inner quote is going to be. So you need to use an escape sequence, which basically means I'm going to put like kind of a format in there that tells the language in my string I have a special letter or a special character. And how I do that is using the tilde q or tilde anything else reference in the manual. I'm using tilde q because that means because that will transform my tilde q into a quote. As you will see over here, it'll put the whole entire string in quotes, and double quotes specifically. Now that we've learned that, we've done a few things here regarding strings. And of course, as you guys can tell, comments, like I wrote here, are just single quotes. So single quotes are comments, single line comments. Alright, so the next thing we're going to go into is some different data types, such as the Boolean data type. So the Boolean data type, easy as saying bool and then equal to true or false value, not false. That's something completely different. I don't even know what that would be. And I'm going to just imply that this no is equal to false. And yes, you can print these like you can implicitly print just about all the other primitive values or primitive data types. So yes, print no, and I'm going to look here, true and false. Just like I expected, no is false, yes is true. I can switch those around, but that wouldn't make any sense. That's as simple as Boolean values get. They're more useful when you start doing some expressions and logic, but we're not going to be doing that right now. Control flow kind of stuff. Next, we're going to look at numbers. Numbers are important when you're programming. So we got local number, and the most common value you'll probably be working with is the integer, which can be any whole number, negative or positive. So I'm going to be working with the number 10. And next, people want to probably use some fractional values like 10.5, 3.9, something like that, or even pi. We're going to use the commonly used data type for that, which will be double. Some people like to start off with float, but double is more appropriate for most things. Now we're going to print some math happening here. Number, or 10 plus 2.5, 10 plus or minus 2.5, 10 times 2.5, 10 divided by 2.5, and this should be 12.5. This should be, I don't know, 7.5. This should be obviously 25, and this should be 4. Now if we see that happening, we should see 12.5, 7.5, 25, and 4. And you should imply that if I can print this expression, I can print these numbers. Next, the last few things for math we're going to use, not so commonly used except for mod, which is 10 modulated by 4. And what mod basically means is, if I divide the left side of mod by the right side of mod, so here it's 10 divided by 4, if I have a mixed fraction, which will give me 2 and 2 over 4, then I should get the value of the, I think it's called numerator, over the denominator, which would be 2. And the next two things that we should be focusing on is bit shifting. And what we'll be working on is shifting left by 1, which is the binary equivalent of 0, 1, 1 bit. And when you shift left by 1, you're simply multiplying by 2. Now, when you shift by a number, and this doesn't necessarily mean you're multiplying, but in the case of 1 bit, that is indeed what it means. And if you're more interested in this, either take a class at school over lower level ideas like binary, or you can look it up online, of course. So shifting left by 1 should multiply it, which just means that if I have a number, its binary equivalent will be a series of zeros and ones, and it will take that series of zeros and ones and insert a 0 at the right of it all and shift all that series of zeros and ones to the left, effectively making it a larger number. And in this case of shifting it over by 1, you're doubling its value. So if we're shifting number, which is 10, we make it 20. And now the same idea is true when you're shifting by right, and we're going to shift it over that series of zeros and ones over to the right by one place. And that'll effectively be the inverse of shifting left, which means that we're taking number, which is 10, dividing it by 2, and ending with 5. Now let's give that a go. I'll press F5. And exactly like I expected. The last thing we'll go over, since we just covered some math and the basic number types, is the arrays, which allows you to store a whole bunch of data types or a whole bunch of data into one variable. So we'll use our local variable. We'll call it numbers here. We'll define it as a integer array, and we can actually define this number array on a separate line. We can at least say what type of what the variable is, but below it, since we know what kind of data type it'll be, we can set it equal to a new allocated data collection here. So we'll say new int. We don't even need to define. We could just do this, which will just give us a integer array of 4 null values, which in this case defaults to 0. But we want to define it somehow. We can do that all in one line. And we don't even need to define the length of this. So we just need to get this right here, the integer with the, I don't know what they're called, braces. And get inside your parentheses, you just type in a list of numbers 1, 2, 3, 4, 5. And now you have access to a numbers array, which you can reach each of those numbers by doing the variable name, brackets, and then put the index, which starts at 0, unlike other languages like Lua, which start at 1. And obviously you can continue doing that until you're past the length of the array where it doesn't make any sense, and it'll give you an error. And just to make sure we know that it's not printing just some random number or the index itself, we can put some more meaningful numbers in here, like 3, 43, and 22, and you can see that those index values provided here do match up with that. If you made it this far in the tutorial, thank you so much for watching. I hope you enjoyed it. If you did, please leave a like, please leave a comment. Both of those really motivate me to continue working. And if you haven't subscribed already, please do subscribe. I will be trying to make more videos as they come to me. Of course, this is only a series, so there definitely will be more of this. That concludes the video. Thanks everybody for watching. Have a good rest of your day.